Hello, I'm Robert, fact checker and science blogger, and I'm here to help people scared of various things. And this time's it's about this conspiracy theory idea that coronavirus is a man-made bioweapon. By the way, just give a bit of background to me. I do a lot of science blogging, and so I've got a background in being able to check academic sources, and all I'm doing here is like responsible science reporting. I'm not talking about my own research. So anyway, this is to answer this conspiracy theory idea. So first of all, they talk about this patent. So here's an example patent, and you might look at that and you think, oh, this patent is for coronavirus, a newly isolated human coronavirus. And if you not read that very carefully, if you're not thinking very carefully, you think patent. Now, patent means that someone's invented it. And so the coronaviruses must be invented by humans. But no, that's not what it means. Back in 2003, when this patent was taken out, then the US permitted patents for natural sequences. And there was quite a lot of controversy. I remember back then, lots of people talking about if should that be permitted. It doesn't seem right. How could someone put patent say someone sequenced my own genome, and does that give them the right to kind of patent the genes that make up my own body? So there was a lot of controversy about that, and then it was overturned in the US in 2013. The Supreme Court made a decision that these patents aren't valid. So it's not actually even a valid patent, not even a valid patent anymore. And notice it says coronavirus isolated from humans. There's absolutely no doubt about it. This is not invented. It came from humans, and it, as we'll see, came originally from horseshoe bats. So as I say, and then there's a paper, and then this new virus is also, this new virus is also natural. The gene sequence shows it's a virus of horseshoe bats, and it's been modified in some way, and the original one might as well. So this is the horseshoe bat, this little creature which seems to be implicated in all of these, in SARS, MERS, and this new one. If I read right, well, the MERS is from camels, but it may have come from horseshoe bat as well. Let's just double check that. MERS, horseshoe bat. Here's a New York Times one about how bats live with so many horseshoe virus. Yeah, I think one of these. Let's give you an idea of how you can check. You're looking for the most reliable sources. Yes, bats have been recognised as well, you can double check the reputation. That looks like to be a reputable journal, and it says bats have been recognised as natural reservoirs for a large variety of viruses. And it goes on to say that SARS and MERS are both suggested to have originated from bats. Various species of horseshoe bats have coronaviruses, and some highly similar to SARS, and on the and ones that are related to MERS have been discovered worldwide in a wide range of bat species. And other ones as well. So the bat origin, and why do bats have so many viruses? It may be because they live in these colonies in close proximity and easily transfer bats from one to another. oh yes, here we are, how do bats live with so many viruses? And so, yes, I have to have a bit of a read of that. I just covered that this minute. But this is someone, so you have to double check when it's a news story like that. Yeah, look at that. The one bat kicking natural reservoir for all these viruses. And they're not thought to be natural reservoir for the Ebola virus. I didn't know that. It can also carry the rabies virus, not affected. And so they have a tolerance of viruses that much that surpasses all other mammals, according to this. Well, I mean, that makes sense. They eat so many disease-carrying insects. And there's the bats in the great hosts. And so there's a lot of investigation into how the bats are able to handle so many viruses. I'll have to have a read of all this and maybe add this to a future debunk once I've got a proper understanding of it. Anyway, so very interesting. There's lots of good stuff online. Being so interconnected as there's two sides to it, you've got to know how to search for things, and then you go and check back the original source. The New York Times is usually pretty reasonable, but sometimes it makes big mistakes. So you do have to do these occasional. You have to have these checks. Made a huge mistake about the Yellowstone supervolcano, so bad that the Snopes debunk was tweeted of the New York Times article was tweeted by the lead researcher, and they still haven't corrected this mistaken article. So you do have to watch out, even with the most reputable mainstream press. They don't seem to correct articles when they get them wrong. It's very rare for them to do that. So you just have to double check yourself, but they're usually right. So anyway, so that's the horseshoe bat, which you don't really need to say poor horseshoe bat, because it manages just fine with all these viruses. And just it's got a great tolerance for them, if that's right, which I think. Look at his tiny, tiny eyes, because he doesn't use them very much. So this is about how the researchers who found the possible origin for the SARS virus went to a particular colony of horseshoe bats. It's not necessarily it came from that colony, but it's similar to what it came from, probably. Then the villagers that live near had a significant percentage of antibodies to coronavirus, and that suggests transmission from the bats to the humans. I suppose it could be just still transmission from bats to some other animal and to humans, but with them living near the cave. So, one way or the other, these viruses seem to be making this jump quite often, and it's not just recent times, because you're talking about people living near there, and there have probably been humans living near to bats for a long time. But they didn't become a kind of epidemic. So, and then there's the idea that, some seagoing mammals, this is from a market with lots of sea creatures, and one possibility is the beluga whale, but apart from that, then there's so I don't think it'll be selling beluga whales there. So, chickens, bats, rabbits and snakes. So, it turned out that this one, it seems to have quite a lot of connections with with snakes and the viruses that you find in snakes. But it's not a very strong proof. What they looked at is the codon virus. So, if I pick up a Wikipedia page on codon virus, I can explain that to you. Yeah, So I think that's quite a reasonable page. So if it's got that picture that I saw, there's a preview there. Has it got that somewhere? No, it hasn't got it. Oh yes, there we are, right at the very top. So what you've got out here, these are the, I'm not sure if I, so here we are, you've got the, these codons, which can then, is the number, these sequences, so they come, you have little sequences of 3 of the RNA, of the 3 bases, and then each sequence of 3 bases gets translated into an amino acid. And so you've got these alternatives, so UGC, UGU, AU, so if you look at that one, AUA, AUC, AUU, so some amino acids have several different codons to code up the same amino acid. So you've got this RNA, which is a long wiggly line of codons, and then it goes through the ribosome, which translates those codons into amino acids. And out the other side, then it's got a little factory for making amino acids, and so sort of goes through the RNA, 3 bases at a time, making amino acids, which then join together to make the protein. So, this is using the codon. You have alternatives, that or that will both make the same amino acid. There's a lot of flexibility in how you can make the protons from codons. So different animals, if you look at viruses, then they have different sequences of how, and viruses being RNA, sometimes the viruses turn into DNA and become part of the genome even, but normally they're RNA. So and they don't, and they kind of hijack the cell mechanism. I may be getting things wrong here. That's a very rough idea. I'm not a microbiologist. I'm just like science blogger, and I got the idea. I've sort of got a rough idea of how it works. And do correct me if I got anything wrong, but that just gives you a very, very rough idea. So the codon bias means that if it's a virus that comes from snakes, it tends to use one of those codons to code the amino acid rather than another one. Whereas if it comes from, say, civettes, then it would be a different codon that it tends to prefer. And if it comes from camels, it would be another one. So looking at the codon bias, then it seems to be using the kinds of codons that you'd expect to come from snakes. So that's why this paper said that it might be, it looked like it could have gone from a bat to a snake in the market and to humans. Now, the problem with that is that it's very difficult. It's not so easy for a virus to go from a cold-blooded creature to a warm-blooded creature or the other way around. So here's some various experts coming in and saying, oh, this doesn't seem so likely. It's not impossible, but it seems rather unlikely. And so what is the flaw in their argument in this paper? Well, if it is flawed, then the flaw is that the snakes aren't necessarily the only ones that have this codon bias. So they only looked at a limited number of species, and of the ones they looked at, the snakes were closest. But there will easily be some other animal that has the same codon bias as the snakes have. And there are various other possible loopholes in their argument. But they published it anyway. They published it with a very quick peer review because they just thought it was very interesting, and because of the fast time of pace and researchers want to get things done quickly, then they published this very quickly so that other researchers can start thinking about it, whether it is from snakes. It's now, other people are now weighing in and say they don't think it really is. But it's an interesting paper all the same. So anyway, but you can see from that there's no chance at all that it's been made by anyone. It's a very natural thing. You're just looking at how it came from bats to what other creature it came from in order to get to humans. And there's a wide variety of possibilities, because in China especially, they eat a lot of wild animals and birds and bats. And I just want to say that seems very strange to us. But if we were hunter-gatherers, it would be normal. We do, of course, have things like people who shoot grass and they kill red deer and things like that. And people sometimes eat the venison. But there's very little of that goes on in most countries. And but in China, and that goes on a lot. But what we do still have in most countries is eating wild-caught fish. So it's not that different from all the exotic kinds of fish that you might eat. And the main problem is that the Chinese are eating wild-caught animals that's actually illegal and that they're not supposed to be catching. And they're getting these viruses from some of these illegally caught animals. And after the SARS outbreak, then the Chinese government closed them all down, but then they opened again fairly quickly. And then they've closed them all down for the duration of this outbreak. And many people are saying, oh, they should just close them down completely, all the illegal animals that are being sold in China, and just have the legal ones, including legally caught ones and legally hunted animals. Just as we have in the UK, we have legally hunted animals, and then people do sell them for meat sometimes. So, but there's a big push again, kind of pressure on China to close down all the illegal wildlife markets that it has, just as it's doing now for the duration of this. In fact, I think it's just closing down all wildlife, so that's simpler. What makes it more difficult is if they're selling some wildlife that is legally hunted, and then they're selling these, and then amongst them, then they mix in the illegally ones, which get a high premium because they're rare animals. And so, well, not necessarily rare. This is not vulnerable. So this horseshoe bat is not. It's not listed. It's of least concern in the IUCN Red List. So the Chinese, when they're catching and killing and eating these bats, then they're not killing a threatened species. But some of the ones they kill would be. And just to say, by the way, some people are sharing this viral false story that the market sold koalas. No, it didn't. It was a Chinese word that's written on a menu that looks very similar to the Chinese word for a koala, but it wasn't. So just people making a mistake. It was a kind of rodent. What else do we have here? So it's milder than SARS, maybe 4%. Once you're over it, then you're immune to it, and that's the same for all viruses. It's got a 2 to 14 day latency period. It's immune because that's just the way it works. That's how you get a vaccine, and you just have it. You just be constantly ill for the rest of your life if your body didn't fight it off. And in fact, so it's not the virus getting weaker, but the body fighting it off and eventually becoming immune. And so once you get over your flu, then you're immune for that particular flu virus. The only reason we keep getting flu is because flu is very mutable, it keeps changing. And so every season it comes back in a slightly different version. And so the same adult can get flu multiple times. But it's actually a different virus each time. SARS doesn't mutate nearly as much as that. In fact, and it only had one tiny mutation, which actually was a sort of accidental one, that make it less infectious. So mutations just random mutations like that can make it less or more infectious, less or more deadly, but it's no advantage to be more deadly, and there's an advantage to be more infectious, but it just doesn't have enough mutations to kind of try out different ideas. And the SARS virus, it only had one mutation and actually made it less infectious, and then just by chance that one was the one that kept spreading, even though it was less infectious. But probably there were a bit of a bottleneck, and the one that came out of that was the less infectious one. So you don't need to worry about it mutating. It's not very likely that just one random mutation is going to suddenly make it very infectious, and it hasn't mutated at all yet. So anyway, so it doesn't spread easily when precautions are taken, and it doesn't, and so that's what I say here, and you mightn't get symptoms for up to 14 days. So imagine a bio war, and it is true that China has not signed and ratified. I think it's signed but not ratified. I'm not sure. The Convention on Biological Weapons. Maybe I'll just check. But it doesn't take that long to check. Let's just check. Let's check the Convention on Biological Weapons. Signatories. And Wikipedia is usually quite good on this, so if it is first, then there we are. I'm fine going to that. Oh no, it's the arms control situation, that's even better. So yeah, that's much better. So now let's look up China. And not scrolling down automatically. China. So there you are, see China. Then what's it done? Oh, it seems it has. So right. Ratified, accessed. Accession. What's it say? It does seem like it's ratified it. I'm not sure if I'm. So I mean, Wikipedia is quite good in that. So. The parties to the Biological Weapons Convention. Then signatory states. Republic of China. It's deposited. Yes, it's ratified. Signed and ratified. So you wouldn't expect it to have made biological weapons. Wait a minute. Well, that's just the Republic of China and PR. Republic of China is Taiwan. Oh, sorry, that's Taiwan. Has signed and ratified it. Oh, no, you've got to watch out for that. That's as China signed, ratified it. So China has just done an accession, it hasn't ratified it. So yeah, that was rather confusing. He just said, he doesn't say whether it was ratified or accessed. So it just accessed it, hasn't ratified it, and it hasn't signed it. Yeah, I thought that was true. So so China has not ratified the Convention on Biological Weapons, which is that's an understandable reason for people to be a little suspicious. Could China have done this? But I mean, it's not very likely they ever use biological weapons in warfare, and this is definitely not a biological weapon. I mean, just obvious, really. Because what use would it be in war to have something that gives your sword you're in a battle and you want to win the war, and then the people on the other side then you give them, you sort of, you give them something that give them some sniffles 14 days later, and then they die. Maybe 3% of them die a month later. It's not going to work. So absolutely no, it's not a bioweapon. It just doesn't even make any remote sense. Say the war would be over, and this was a very long, protracted war, before the soldiers even knew that they were infected. And then the infection would come back to you, and becomes a global pandemic. I mean, it's not, something that's easily, it's the opposite of what you want for a bioweapon. Something that has very low lethality, that has a long incubation period, takes a long time from then to get sick and to eventually die, and that is very infectious, so it spreads very quickly, so it's very likely to come back to you and harm your own citizens. It's absolutely the opposite of what you want from a bioweapon. Anyway, so no, it's not. So that's all I want to say about that, for people who got scared of this idea.